first thing we're going to do is some definitions on the notes. Random sampling. It uses a chance process to determine which members of a population are included in a sample, and they should all be equally likely to be picked. And the next one is a simple random sample, which will probably be referred to a lot as an SRS. It's a sample chosen in a way that each individual in the population has the same chance of being chosen. Okay, so when we want to do a simple random sample, the way we do it is we start off by numbering each individual with a distinct number, 1 to n, where n is the total number of people I have. And then we can either use a calculator like we did yesterday, or we can use a random number table. We're going to do a random number table today, because sometimes the AP test will have you look at a table instead of using a calculator to do random numbers. So we're going to go over both ways. Yeah. So that's that. This is the problem. It tells us the manager of a mall plans to survey a random sample of 3 stores to determine how they would like, to determine the hours they would like to stay open during the holiday season. We want to use the table below to select an SRS of size 3 stores. So I'm going to pick 3 stores from this group. So the first thing I want to do when I am doing a simple random survey is to number them all. I am going to number alphabetically. So starting at the first one and then counting down. So notice the total number of stores I have is 21. So the first thing I want to take note of is, since 21 is 2 digits, I want to make all of my numbers 2 digits. So I'm going to add zeros in front of all of the ones that are not 10 or more. Then what I'm going to do is I'm going to use this table, and every 2 digits is going to be a number. So I'm going to break the table into 2 digits. Okay, so if I take a look at this table, my first number is, when I break it into 2 digits, 19. Is 19 a number less than 21? Yes. So what I'm going to do is, for now, I'm going to write 19 select, because that's one I want to keep. I'm going to keep doing this until I get to 3 stores, because there's 3 I want. So I'll highlight number 19 to remember that's one I want. Then my next 2-digit number is 22. Is this one I want? No. So I'm going to write skip. It's important that you write each number and whether you're selecting or skipping it, because on the AP test, the grader needs to know why you chose which numbers you did. So this is like explaining your thought process out as you're taking the test. Okay, so I'm going to include this 3, and then that next one is a 9, so 39. What should I do? Okay. My next one is 50. Skip. 34. 34. Skip. 05. Okay. Have I got 3 stores yet? Okay. So then my next one is 75. 62. Skip. 87. Skip. 13. Select. So my 3 stores in the order I got them. What was the first store I got? Okay, my next store? Carter's for Kids. And my last store? Mrs. Fields. If I had done this and say the second number, so like I get 19 and then I get 19 again, I would skip it the second time. Because I can only pick each store once. Questions here on how we picked those 3 stores? Okay, so what's the difference between sampling with replacement and sampling without replacement? What does it sound like the difference is? Yeah, So with replacement means you can get the same number twice, and that's okay. Without means you only want to pick each number once. Okay. And then this last question, how should you account for this difference when using a table of random digits or other random number generator? So if you get a number, you state it's repeated, or if you get a number twice, you state it's repeated and then skip it. Does anyone still need this page up? Okay, so this question is, what does it take to earn full credit on examples like this one about the mall hours on an AP test? It would be enough detail so a computer can follow your directions and get it right. So we have another example. It says, suppose we want to estimate the yield of our cornfield. The field is square and divided into 16 equally sized plots, 4 rows with 4 columns. A river runs along the eastern edge of the field. We want to take a sample of 4 plots. So on the first one, it wants me to use a random number generator and to pick a simple random sample of 4 plots, and then place an X on the plots that I choose. So, probably want to grab a calculator if you haven't already. Okay. So we're going to start writing this kind of like if I was being graded on an AP test. I want to write exactly what I'm typing into my calculator. So I'm going to the rand int, and once I type in all of my values on the first menu, what does it give me on the screen where it actually does the calculations? Does anyone need me to show them how to do that again? So I would go to Math, which is the button under Alpha. This looks terrible on there. Let me turn back on the light so this will come out nicely. Okay, so on Math, then you want to arrow over to Probability. And then this is choice 5 for random integers. My lower is always going to be 1 unless it specifies that it's not. My upper in this instance is how many total numbers I have. So 16. And how many plots are we choosing? 4. So then I press enter to paste it in, and then enter one more time to get it. So in my instance, I got 11 twice. So what I'd want to do is I'd want to do it again so I can get one more. That was... And I'll just do it for one number since only one of them was repeated. So I am going to use the 7 instead of the second 11. But I will write out the numbers I got. No, your numbers, not mine. Okay, and then you need to go cross out all of the plots you just got. So for the second one, it wants me to randomly choose one plot from each horizontal row. This is called a stratified random sample because I am breaking it up into different strata or sections. So I am in my calculator, I'm going to type rand int, and this time I'm picking 1 from each row. So I'm going to do 1 for 1. And I'm going to do that 4 times to get all of my numbers. And in this one, it's okay that I get repeated numbers because each row is a different row. Your numbers might be different, by the way. Okay. The last one on the page is another stratified random sample, except this way I'm going across each row. Each column and picking them. So I'm going down and picking. So I do it just like I did the last one. I'm going to do random integer 1 for 1. And I always go left to right. Okay, does anyone still need more time on this page? Okay, so which method out of these three do you think is more likely to give you the sample mean closest to the real mean? The totally random number one, where we chose from the 16 plots, the horizontal stratified, or the vertical stratified? Huh? Okay, is that what you think, Chris? So on the totally random one, I'm not getting anything, on mine at least. I'm not getting anything in the bottom left away from the river, and I'm not getting anything next to the river. Do you still think that's gonna affect how the corn grows? So do you still think the totally random one is good? Each vertical column, right? Because I'm getting one, at least one next to the river, at least one the farthest away from the river. Okay, so the next thing we want to do is we want to go ahead and figure out our averages for each of these three ones we've done. So over here is how many, this was corn, right? These are how many corns were in each plot. So you're going to go back and match to your front side. So for example, I have the first two and then these two. So I would add 4, 29, 98, and 92 together for my SRS sample and find the average yield there. And then I'll do the same thing for each of my stratifieds. We're going to add them together and divide by 4. And then just round to 1 decimal place if you need it. So if you found all of your averages, go ahead and put them on each bar or number line. Okay, so 70 is the average yield. Who had the SRS that, or out of the three, whose SRS was closest to the average yield? And that's your closest number? I don't want the highest one, I want the one closest to 70. So I have two. Okay, so one person is closest on the SRS. Who's closest on the row? Okay, 4 people are closest on the row. So then, who's closest on the column? Okay. Okay. So it looks like about 14 of you were closest on the column. So, does that match what we predicted? Yeah, for the most part, the column gave us the closest number to the true average. So, we have some more definitions. Strata is a group of individuals in a population who share characteristics thought to be associated with variables being measured in the study. I will write that down. Okay. So one thing I want to point out before we move on to the next one, the singular of strata is stratum. Okay, the next one we have is called a stratified random sampling. This is not abbreviated, so we don't get it confused with SRS. It selects a sample by choosing an SRS from each stratum and then combining the SRS from each stratum into the overall sample. So what we did on the stratified by row and column. The next one we have is a cluster, so a group of individuals in the population that are located near one another. So cluster sampling is selecting a sample by randomly choosing clusters and then including each member of selected clusters in the sample. So, for example, if I wanted to do cluster sampling in here, a good way for me to do that would be to use your groups that you're already sitting in, and then if I randomly selected 2 groups, and if I numbered you 1 through 6, and let's say I got 3 and 4, I would include all the people sitting in groups numbered 3 and 4 for my sample. Does anyone still need this page up? So how is a stratified random sample different than a simple random sample? What did we do on the stratified ones that was different than what we did with the SRS? So I broke them up into smaller groups before selecting my samples, right? Oops, I wanted similar, not smaller. Okay, so what's the benefit of using a stratified random sample? What happened when I started breaking things down into the stratified by row and column? What did I get for my numbers? I got closer to the average in general, and then I also, on the stratified by row, I got at least 1 number from each row, and I got on the stratified by column, I got 1 from each column. So it guarantees that I'll get samples from each group. Any ideas on how I should choose my variable? Yeah? Or no idea? So it's a good idea to choose a variable that all of the data can have that will eliminate sampling bias. So on the one that we did by stratifying by column, we controlled the variable where some plots were next to the river and some were super far away. Bless you.